Hi everyone, here in this video I will demonstrate you the VLSI design flow, that is actually from RTL to GTS design, that is VLSI design flow. In this video I will show you the RTL to Netlist part, and in another video I will show you physical designing part. So to make any fabrication or any chip, first you have to write the RTL code for that. So let's say I have written the RTL code. I'm demonstrating you. So first you have to write your specification in terms of either Verilog or VHDL. So let's say I am written my specification, what I want to perform from my chip as in the Verilog. So here I have performing 4 different operation depending on the value input value C. So if the input is C, then it is performing 4 different tasks. That is either this is a frequency divider, comparator, XOR operation, and adder operation. Depending on that, I have written the Verilog code for different. So the next step will be you have to demonstrate, check whether you have achieved the correct functionality or not. So for the checking, I have to write the test bench. So I have written also the test bench. So this is the test bench I have written to check whether my RTL code is working correctly or not. So let me check the RTL code. So I am using the cadence tools, CSH. So this is IMC I am using for the checking of our tool. So first I have to check test bench, the input signal A, B, C, clock, out, and reset. So I'm sending into send to, click on waveform, send to waveform. Sorry, send to waveform. So here you can see this is the IMC tool. You have to now click on run. So as you can see here, zoom out. So as you can see here, depending on the different value of C, this is the value of C. Depending on the different value of C, there are different outputs. So let's assume our C value was 0 first. So it was acting as a clock divider, frequency divided by 6. So let me show you whether it is correct or not. So the input clock is this, and you have to check output clock. I am assigning the output on the only a 10th edge. So you can see 1, 2, 3, 4, 5, 6. 6 clock divided by 6 is coming as output. So depending on the C, there are different many operation of performing adder, XOR, and that things. So this is the functionality check for our RTL code. So our RTL code is working correct. I have verified that. Now the next step is whether our test bench is able to detect all the RTL code, or it is just few set of RTL code, whether it is correcting. So that will be defined by code coverage. What is the code coverage of the test bench? So let me check the code coverage of the test bench, whether it is covering all the test cases or not. So see, the code coverage of test bench is 100%, which each and every line of the RTL code is verified and it is working perfectly fine. So if the code coverage of test bench is correct to 100%, then you have written a very good test bench. So now the RTL part is completed. We have the RTL code of our specification. Now from the RTL, we have to map it with the technology dependent library, that is logic synthesis part. So for the logic synthesis part, I will use the Genus tool. So let me close first the previous windows. So I will use Genus. So I have written a script for that. Let me show you the script, script.tcl. This is the script I have written to perform the logic synthesis. So I will run this script. So source space DC. So after doing this RC script, your it will perform the logic synthesis part. That means it will map it with the technology dependent library, whether whatever we have written in. Let me show you the script. See here technology in the .lib folder 90 nanometer library it is mapping, and with slow.lib file, and the top.v your HDL code, and the different constraint I have written in the SDC file I will show you. So let me show you first the SDC file. So constraints are in the here in the .hdc file. So I have taken the clock period, rise time, rise delay and fall delay, rise transition, fall transition, and clock uncertainty 0.1, clock latency 0.1, and then input delay, output delay, input transition, and load of 0.1. So this is the RTL. This is your constraints which I have written for the synthesis part. So the tool will have mapped the done the operation, and it will give you a synthesized netlist. So it is the synthesis report. In the SDC one I have written folder. So in the SDC one you can see the synthesized netlist.v folder. It is the synthesized netlist. See, you can see from the library it has mapped all the gates your RTL code with the technology library, where NOR2 BXL gate, OAI21XI gates. So your netlist is mapped with the technology dependent library. Means now you have the netlist. I will show you also in the genus. So this is your technology dependent library net schematic. This is your RTL, whatever you have written in the RTL code, this is the schematic of that one. So you can, if you zoom out, you can see the different pins. You can see different gates, as you can see. And this is your B pin. And this is your clock pin, reset pin. And this is at the output side. This is your output pin. You will also see that. So now you have got your RTL on the depending on the mapped with your technology dependent library. This is the output port. So after that, what you have to do now, you have to check whether the netlist is working as same, is giving same behavior as you have written in the RTL or not. So for that I have used the LEC tool, logical equivalence checking, in the conformer tool. So let me close the previous steps. Open internal. So this is the logical equivalence checking in the conformal. So it has checked all the, and it has generated its report. So let me show you the report, formal equivalence checking, and netlist equivalence check. In the log file you have to see. So see, the comparison result is pass, means you have your netlist is working as same as the you have written in the RTL. If you have you do any change in the netlist, I have done few changes in the netlist. So this is the bad netlist I have written by changing the few definitions. So if you check these two netlist, then it will show you a report in, it will not show you pass. So let me show you also. So you can see this fail, because I have written I have changed the netlist here. So if you will change something or it will not work as the RTL you have written, then it will not compare and it will show you the fail result. So now we have our the generated netlist is working as same as the RTL code. Now what we have to do, now we have to also take care of the stuck faults which might occur in the designing due to error faults. So for that, to detect the fault perfectly efficiently, you have to insert the scan cells. So you can also insert the scan cell by scan cell PCL script. I am not doing that. So this is the RTL. I am doing up to the synthesize netlist.v we have generated. So our the logic synthesis part is getting completed. So in the next video, I will show you how from the logic synthesis, after logic synthesis from the generated netlist, how you can do write the GTS file that is actual goes to foundry and help to manufacturing of the chip. So thank you.